say welcome everyone to the Scripps Coastal Processes Group annual webinar sponsored by the California State Parks Oceanography Program. The purpose of this webinar is to provide state, regional, and local beach managers with an overview of the state of our beaches and the coastal research projects that we are engaged in. A couple formalities before we begin. We'll allot a few minutes after each presentation for questions, and we'll also be on hand after all the presentations for additional discussion. Also, a heads up that we will be recording this webinar, which will be posted on our website at the address provided in the agenda and should also be in the chat. Nick will start off today's webinar with an introduction of the State Parks Oceanographic Research Program. So go ahead, Nick, take it away from here.
All righty. I am sharing slides now. Let me know, does that look good? I see some nods. Yes. All right, perfect. Well, I will get started then. So good afternoon, everyone. My name is Nick Da Silva. I'm a senior environmental scientist with California State Parks, and I'm the staff lead for the department's oceanography program. I want to thank everyone for attending today's webinar. This is an annual gathering that has occurred for at least the past 4 years and is intended to kind of offer a deep dive into notable coastal monitoring results and advancements produced through our partnership with Scripps Institution of Oceanography at UC San Diego. Before we kind of jump into all of the science, I'm going to give a super quick introduction to the underlying partnership that supports a lot of the research and coastal monitoring work that we're going to hear about today. So for those of you unfamiliar with the program, we partner, we being state parks, with public research institutions to develop and implement best available science for public safety, recreation, and coastal resource management. The program originated in about 1974 with the goal of establishing wave condition monitoring for California. It's been shuffled through a couple state agencies since then, but today the program resides within State Parks' Natural Resources Division and maintains support for an array of projects focused on understanding, assessing, and forecasting mostly physical coastal processes across California. Today we're going to be hearing specifically about the work out of the Coastal Processes Group at Scripps, but if you'll bear with me, I'll give a really quick lightning tour of the program's scope so we're all kind of on the same page. One thing I do want to touch on is that one of the real advantages of this program is that it serves as a through line between California's coastal managers and scientific experts. So, please use today's webinar as an opportunity to connect and ask questions directly with the Scripps research team. And, on the back end, please don't hesitate to reach out if you have follow-up questions, if you want to connect and discuss how we can better expand or adapt our work to meet your local needs. That kind of end user feedback is super valuable to both us and to our partners at Scripps. And so always willing to sit down and talk about how we can improve our work. So really quick, I'm going to run through a couple of the research areas that this program supports. As I just mentioned, the foundational goal of the program was to develop high quality wave monitoring for California. Today, State Parks funds approximately 40% of the California Coastal Data Information Program, or CDIP, buoy array, as well as the California Wave Model. We also support several CDIP rover buoys, which can be strategically deployed in the near shore to collect high-resolution, site-specific data to inform project-level questions about local wave environments. Complementing our offshore monitoring, we also partner with Scripps and UCLA to conduct regular coastal processes and hazard monitoring for state beaches. Today, the Scripps Coastal Processes Group leads one of the most comprehensive shoreline monitoring programs worldwide, which we'll hear a lot more about shortly. We also fund the Shore Stations program, which maintains 10 daily active ocean temperature and salinity monitoring stations from Trinidad to La Jolla, including the Scripps Pier Station, which began in 1916 and today represents the longest running daily sea surface temperature record in the entire Pacific Ocean. In addition to our ocean and beach work, we also support several projects focused on estuary dynamics, informing coastal management questions about how estuaries and coastal wetlands impact coastal flooding, sediment transport, beach conditions, and a whole bunch more. And finally, we're working with Scripps to leverage a lot of these lessons learned and new technology to expand our capabilities to do this type of work outside of the San Diego region. For general coastal change questions, we're looking at how satellite imagery can be used to analyze shoreline change and beach widths over time. And for more kind of site-specific questions, we're also working with Scripps to develop autonomous coastal monitoring stations, which we'll hear about today, and are being strategically deployed at select locations within the state park system to inform priority recovery actions and resiliency planning. And, we're still kind of soliciting offers for locations where one of these stations might be useful. So, if you've got somewhere in your parks that or in other lands that you manage that seems like it could benefit from this type of really site-specific local monitoring, again, please reach out. In addition to kind of the data and the science, we also work to translate those results into applied deliverables to inform coastal management. That takes the form of things like reports, newsletters, websites, webinars like we're at today. And again, a big part of my job is to work with managers at state parks and elsewhere to determine how we can best translate that science to meet local needs. So again, please reach out. Moving away maybe from the management side, I think it's also worth reiterating that program-supported research has made a significant contribution to the fundamental science underpinning coastal oceanography in California. Researchers have acknowledged oceanography funding in something like 273 different peer-reviewed publications. Those in turn have been cited in 14,000 plus articles, including over 300 government policy and planning resources. And all of that has been accessed, at least as far as my bean counting goes, by an audience of at least 11 million readers. Finally, I also just want to acknowledge that, this partnership provides a unique service in also routing state funding to support students and staff at partner universities. I think there's real value that we're able to do all of this great work while simultaneously investing in the education and the technical development of the next generation of scientists and managers and decision makers. And, one cool thing about this being a program within state parks is we can also leverage our Division of Interpretation and Education to develop additional coastal processes science communication content targeted at school group and park visitor audiences. And then finally, I just want to make one more pitch for partners. We just participated at a great event down at Scripps for their Coastal Resilience Summit in 2024. Always happy to come share our expertise, connect folks with the coastal scientists that might be working in their region, and putting on events like this webinar today. So, with that, I'll get off my soapbox. I'll hand the microphone back to Scripps so we can learn about all the cool science updates. And maybe just as one more reminder, this will all be recorded, and please feel free to share that recording with all of your colleagues down the line once this is made available. So thanks. Back to you, Michelle.
Thank you, Nick. Our next speaker is Dr. Adam Young, one of the principal investigators for our group. Today, Adam will provide an overview of our beach and nearshore monitoring program and our efforts to expand beyond San Diego County.
Can you guys see my screen okay?
Yes.
Yes? Okay. Okay, yeah, I'm going to briefly talk a little bit about some of the monitoring we're doing in San Diego. And then, yeah, a new project that we have where we're trying to increase our monitoring capacity outside of San Diego. So some of our primary survey tools we have in San Diego, which tools such as ATV that you see here, a jet ski that's outfitted with a depth finder, and a dolly that we push out in the surf. And these tools are used to map the beach sand levels onshore and offshore along transects on our coastline. Some of our newer tools consist of drones and mobile LiDAR systems, such as this truck here. We also take high-resolution photographs with these tools as well to map the coastline. One of our newer tools is a shallow water multi-system, which provides very high resolution and detail of the subsurface and offshore conditions. So our survey started in, we have two primary survey areas in San Diego County. Our first, one of our survey areas is in South County that goes from Coronado down to the Mexican border. These surveys started in 2008 and primarily in the Imperial Beach area. And then we slowly increased our capacity over time. So currently we're surveying about 20 kilometers of coast from Coronado down to the Mexican border. Our other main survey area in San Diego is in northern San Diego County. These surveys started back in 2001, so this is a very extensive long-term data set that we've collected. And these surveys have also increased over time. They started in Torrey Pines and currently, and then slowly expanded over North County. So currently we're surveying from La Jolla Shores up to Oceanside 2 to 3 times a year, and then from Torrey Pines up through Carlsbad every week. So in addition to those regularly scheduled surveys, we also have rapid response surveys, such as when we have large landslides along our coastline, or if we have a large storm event. This is an example of a large wave event we had in January 2023 that coincided with a relatively high tide. So you can see on the bottom left, this is Mission Beach Boardwalk that got completely flooded. On the bottom center is the Carpling shoreline, which took a lot of damage, and then other beaches on the right here. Basically, a lot of the beaches, particularly North County, San Diego, were completely stripped of sand, left down to bedrock and cobble in our beaches. So we were able to get out and survey both our South County and North County survey site immediately after this event. So putting all this together, on the horizontal axis is time. So again, our survey started back in 2001. On the vertical axis is location. So this corresponds from the Mexican border up to Dana Point. And each one of these bars represents a survey. The different colors indicate the type of method that was used. So we have a very extensive database, one of the largest in the world for San Diego. We have over 1,700 surveys in the database, currently collecting probably 50 to 100 surveys per year. So if you haven't seen what this type of data looks like, this is an example of some LiDAR data that was collected in Torrey Pines. So the colors are elevation. Just to give you an idea of the really high detail of data that we're collecting, these are, this is a kind of a crowded day on the beach. These are people you see here. So not only are we collecting these high resolution three-dimensional models, but we're also collecting high resolution imagery that we can add to these models, and it gives us a whole nother type of information that we can use to study the coastline with. So what's really great about these tools is that in the past, we were primarily just focusing on monitoring these transects of sand and bathymetry offshore, but these new tools are allowing us to map all these different components of the coastal system and how they interact. There's various feedbacks in all these different parts of the coastal system, so it's important to monitor them all together. One of our newer tools that we've started to develop in San Diego is a new tool for coastal managers. So we have transects spaced every 100 meters along the coastline. And essentially, there's a new web browser we have that you can go in and click on one of these surveys or one of these transects and view all of our data for that particular location. So each one of these gray lines here is one of our survey lines, and then it'll be populated, colored with the 3 most recent surveys, so you can get an indication of the current beach state. And we are hoping to expand this statewide with additional funding. Another project, this is not state parks funded, but thought might be good for people to be aware of, is that we have a different state funded project that's collecting statewide airborne LiDAR. This project started in the fall of 2023. So we've done 3 surveys so far in the fall of 2023, the spring of 2024, and the fall of 2024. So this project, we're collecting airborne LiDAR imagery, hyperspectral, infrared video across the entire state. This project is funded for about another 1.5 years. So now I'll talk a little bit about one of our efforts. A lot of our research has been primarily focused in San Diego, but we want to be able to expand our research capacity outside of San Diego. The other thing that's challenging is that when we have a storm event, we're often out scrambling around trying to collect data in different places. So we're trying to develop autonomous coastal hazard monitoring stations. These are a couple examples of systems that we have been testing in San Diego. So for example, we have 2 in San Diego, one in South Carlsbad, one in Torrey Pines, and these generally consist of cameras and continuous learning low-cost LiDAR scanners. So we're collecting real-time data that we're providing in dashboards so we can monitor the hazards in real time. So some of the types of applications for this project that we can monitor, we're trying to, be able to monitor a variety of coastal hazards, such as beach erosion, beach nourishment, wave run-up, flooding, estuary closures, looking at the bathymetry offshore or land size. These are just a couple of applications that we can address with these autonomous remote hazard monitoring stations. So this is an example of some image data, so we can rectify the image, develop methods to extract the shoreline position and track it over time. This is an example of some data from one of those low-cost LiDAR scanners. What you're seeing here, the colored areas here, that is the water surface, and you can see essentially from going from left to right, those are waves washing up over a beach. And so we can use this type of information to monitor when and where waves may be overtopping a particular location. In addition, we can use this information to develop and improve coastal run-up models. And we are collecting continuous data in these areas. So what we can do is we can get very detailed information of beach change. So this is just an animation of daily beach change over a particular area. You can see the beaches accreting. But again, these are really, because we're collecting data continuously, this is allowing us to collect really important information that we would otherwise not be able to obtain, particularly during hazard events. Hazard events, oftentimes, we can get there before or after, but getting data as the hazard is occurring is really what's important and helpful for these remote monitoring stations. So this is an example of some cameras that we have installed in Solana Beach that are monitoring a recent nourishment project that was deployed here. So this is prior to the nourishment, and you'll see the nourishment getting built out here and just the huge impact that this particular project had on the area. Here you can see it come down. So we'll be continuing to monitor this particular area, both with our cameras as well as the offshore bathymetric conditions as well. So in our quest to move outside of San Diego and start collecting data elsewhere, we've been in discussions with state parks of trying to understand what the challenges are and where they are occurring. So a couple winters ago, we had a very extreme winter with a lot of rain, large waves that had a lot of damage to California state parks. In particular, Seacliff State Beach was really hammered. And so this has been one of our first sites that we have been working on to establish a remote coastal monitoring station. On the left here is the our camera network that was set up a few weeks ago. On the right-hand side here is our initial dashboard where you can go on and look at the conditions. During the installation, we also did a bathymetric survey as well as a topographic survey that we can use to rectify these images. Another part of this project does include offshore sensors, so we did install a standard CDIP buoy offshore, and this wave data is available already online on the CDIP webpage. And in the future, we're going to integrate these different data sets on a new dashboard. The other part of this project does include another type of offshore monitoring where we're calling them smart moorings, and basically they're going to go next to the CDIP buoys, but these moorings also include temperature and currents. So we're really developing a system here to monitor real-time wave conditions and shoreline change to help predict and monitor coastal hazards. So Seacliff was our first site, and right now we are looking at McCarraker State Park as another potential site. Was just up there about an hour ago, so I'm in my car doing this presentation. And so we have one more site that's funded. McCarraker could be one of them, but again, we are looking for another additional site for one of these remote monitoring stations. And that concludes my presentation. I'm happy to answer any questions.
Well, while folks are thinking of questions, I can jump in with one, Adam. your team is looking at such a different suite of tools and resources, right, to capture coastal processes for folks who, may not have the advantage of having all of this ongoing research happening in their backyard, but, are interested in these questions, want to understand how their beaches are changing. Could you speak a little to, as new technology develops, as we look forward, where you're seeing the most I don't know, actionable results, right? Like what's getting you the data that you feel like is most interesting to management? Is it the satellite imagery? Is it these remote stations? Is it just like the value of a long-term data set? Kind of curious from your lens, kind of what has shown to be kind of the most useful over time.
It's a good question. I don't know if I could single out one. I think they all really work together and are really addressing sort of different questions. So the remote monitoring stations are really nice because you're getting real data during the hazard, which is really data that's really just hard to get. That, we can't get that with the typical surveys. The regular surveys we get are great because we can cover a very large area and they're very accurate. The satellite data is awesome. It covers a huge area. It goes way far back in time. The downside is that, the accuracy isn't perfect as much as, like, say, a LiDAR survey, and Bill's gonna probably get into more of that, and I'll let him talk about that. But each one is really, like collectively is really kind of complementary to each other, I would say. And I see Mike is asking for a link to the viewer. So the viewer is basically ready, and we're going to get that out very soon. I think we just have a couple things to test it, but it's basically ready, so I can send that to you.
Sounds good, Adam. Thank you. And I appreciate all you're doing here. It sounds really awesome that we're going to be able to have some good data sets to help us answer, hopefully, some questions, at least down at Torrey.
I'm also happy, Adam, if you want to let me know when that viewer is available to kind of send it out to the whole listserv that all received this invitation and other things that come out from our like oceanography at Parks email address.
Okay.
Okay, we can take other questions after the next presentation if anyone has anything that they want to discuss. So our next speaker is Dr. Bill O'Reilly, a Scripps Research and Development Engineer and the lead author of the San Diego County Beach Report. Bill will update you on the state of our beaches and what may be in store for us this coming winter. He'll also present a new perspective on past and future California-wide beach change. You're on, Bill.
All right. Are you seeing my presentation slide or the
Yes, you're
Yeah.
good to go.
the normal one? Okay, good. All right. So yeah, in my talk today, I want to say that the beach report is out. It's online if you want to look at it for San Diego, the most recent version. Today in this webinar, I'm going to actually show you some things that aren't in the beach report itself, but are related to it. First, we had a coastal resilience summit here at Scripps in October that Nick mentioned, celebrating our 50 years of the state oceanography program and its support here at Scripps. And so as part of that, we highlighted some aspects of our data set, our long-term data set, that help us ask certain questions like, what's the condition of our beaches right now this fall after 2 severe winters within the context of our 25 years worth of data? Where is the nearshore sand now? In places where we have our jumbo jet ski surveys, we can track where the sand has been displaced offshore, as well as providing our winter outlook. Today, I'll kind of give an abbreviated version to kind of behind what's presented in the beach report itself. And then after that, I do want to shift to the future of our report, and that's that we're going to be adding satellite data, shoreline position data, to the report starting next year. And that's really going to be a statewide product. And but it's born out of the fact that we're able to validate the satellite data against our San Diego survey data set to understand what it is and what aspects of the satellite data we feel are reliable and useful at this point, and take that to provide satellite-derived information since 1985 at pretty much all the state beaches in California going forward. All right, so this is part of my summit talk, and what I wanted to show off was that we have this cool 25-year data set, so we can put our current state of our beach in sort of a 25-year perspective as to you know, how it's doing, especially after 2 severe winters. We had the atmospheric river winter last year, and now this El Nino winter this previous year. And so 2 bad winters in a row. You know, what's the state of our beaches compared to their long-term health? And in doing this, we included some of the other beaches that we survey in between the state beaches, Imperial Beach and Del Mar and Solana Beach and Oceanside. Of course, they're all interrelated, and because the sand tends to migrate down the coastline. So you know, from a state beach management point of view, you need to kind of know what your neighboring beaches are up to anyhow. So the way to kind of address this question of the state of the beaches, we can use our long-term data set of fall beach widths only. Fall beach widths are kind of cool. If you only can survey once a year, fall is when you would do it, because that's when the beaches sort of return to as wide as they're going to get for the year before winter waves start to erode them again. And that tends to, they sort of grow out to that in September and October. They don't change rapidly at that point, so the exact day you survey is not a big deal. So fall surveys are cool if you did it every year. You know, for many, many years, you start to get a really good picture of how the beach is evolving in the long term. So in our case, we can combine, we can combine 2 data sets. Let me see if I can go backwards. Here we go. We can combine 2 data sets, our airborne LiDAR, which we started back in the 2000s. There was a 1997 airborne LiDAR by NASA. We did airborne LiDAR from 2002 to 2010 or so. Then we mix and match with some other people's LiDAR. And then we had mobile LiDAR from our truck starting in 2017. So you combine those 2 data sets, we have fall surveys, LiDAR surveys for most of the years, for the last 25 years or so. And so this looks, this is the kind of picture you can draw with the LiDAR data. So this is just the along-shore beach width. So this is the entire area covered by the truck these days. So from the Tijuana, the north side of the Tijuana River mouth, up through Silver Strand in the little left panel, and then from the south end of Torrey Pines, Scripps Canyon at Blacks, up to Oceanside in the right-hand panel. And you see I've highlighted the different sections of the beaches, the different state beaches, as well as Del Mar and Solana Beach in there. And I've also marked on it the important inlets along the coastline, the drainage sites, as those tend to act as barriers and divisions between the different beach segments. So this is what you get from the LiDAR itself. So there's a lot of variation in beach width, but most of this beach width variation is actually driven by your definition of the back beach. So lowland areas, like in South County, the back of the beaches can be quite far back. It's usually parking lots or the roadway define where that is. And then as you get into North County, it's often defined by bluffs and cliffs. So narrower beaches with that backing. And so a lot of that variation you see is just kind of your definition of what your back beach is. However, because we have 25 years worth of data, we can compare this to their average. So 2024 compared to the long-term average beach width. And now you start to see that some interesting structure here. You can see that Del Mar is above its long-term average there in the right panel, and Solana Beach, which just had that beach nourishment, is well above its long-term average. And you can see some other areas are well below their long-term average up in Oceanside at the far right-hand side. Oceanside, well known for having very narrow beaches right now. So So you can see with this long-term average, you can see this wide variation in beach widths as you go along the coastline, depending on what your back beach is. So really kind of the most useful way to look at this is to look at the width relative to its long-term average. So relative to that black line, when you plot it like that, it looks like this. So that's the same plot as before, but now it's relative to its long-term average. So now we're looking at the anomaly from its average over time. And so the green areas, so above, means that it's wider than normal, and red means it's lower than normal. And so now you can see that Solana Beach really stands out with its nourishment, and also the nourishment that was placed at Moonlight also stands out. And you can see a lot of places are running below average, which is not surprising after 2 severe winters. And up in Oceanside, Carlsbad, particularly below average, but you can see also South Torrey Pines has some very below average areas. Interestingly, Del Mar is running above average as well. You might think that maybe that was due to the nourishment, but that's not, that it was actually running above average before the nourishment was put in. So one more thing you can add to this plot using this long-term data set that we have is you can actually plot the background range that has been observed along the coastline. And so that's the purple background there. So now you really have a sense of where the beaches are at relative to their long-term average and relative to the range that they've possibly seen in the past. And so now we can see that Solana Beach is just sort of blown past anything that it was before. And this is not surprising given the size of the nourishment. You can see Del Mar, North Del Mar is about as wide as it gets. And you can see up by Oceanside and North Carlsbad State Beach that they're about as narrow as they've ever been observed before. So these are the kind of cool things that we can do when you have a long-term data set, is you can kind of give a real perspective on the state of your beach right now. And like I say, these fall surveys are particularly interesting because of the fact that they really give you a good picture of the long-term condition of the beach. So I said that maybe I didn't say before, but I'll say it now, that our beaches are in pretty good shape, given the fact that we've had 2 bad winters in a row. And the reason I say that is because when you put last year, so after the atmospheric river winter, when you plot that on there as the fall 2023 anomaly, here is the red line, you can see that after this El Nino winter, a number of the beaches are actually better than they were in fall 2023. Most of Torrey Pines and Del Mar, all the way through, with the exception of Oceanside and Carlsbad State Beach to the north, and Silver Strand, the north end of Silver Strand is running below average, but kind of stayed the same since 2023. But because of the fact that the orange is sort of lifted above the red overall, that's a good sign that the beaches are actually doing better than they were in 2023 overall, which is a little surprising after an El Nino winter. So we really did sort of dodge a bullet there, I think. And I think most of this is because of the fact that while there were some pretty severe waves this past January and February, the beaches eroded pretty badly. The remainder of the winter was relatively mild. So March and April were pretty mild, tail end of this El Nino winter, and that allowed a fair amount of sand to move back shoreward. And we had a very nice sandbar in the springtime, and that connected in the late summer, early fall to the beach. And so we actually ended up being in a little better shape than the previous fall. Just so yeah, how are we doing after 2 stormy winters? Well, we're below average, so below the horizontal 0 black line there in a lot of places, but in pretty good shape for after an El Nino year and after 2 bad winters in a row. So that's kind of the silver lining there. The exception may be up in Oceanside, Carlsbad State Beach, and the north end of South Carlsbad State Beach that remains pretty well below average here, and kind of looks like perhaps an alongshore erosion wave is propagating down the coast. Because Oceanside has become so sand starved, there's really no sand to propagate down the beach. Okay, so that brings us to the next question of, well, the beaches are more eroded than normal. Where did the sand go? And for a section of the coastline, we can answer that question. And that's really for Torrey Pines up through Cardiff State Beach. This is the region where we do our so-called jumbo surveys with our jet ski and dolly, as well as the beach surveys. And in these areas, we can actually map nearshore elevation changes or anomalies compared to the long-term averages. So here's our little picture of our jet ski and dolly that do that for us. And so this data set goes pretty far back, depending on where you are in this region. It's varied a little bit over time where we've surveyed, but some of the areas have as much as 20 years of data. Others are 4 or 5 years worth. So for starters, we can make just a baseline map based on our historical survey data of the nearshore zone from Torrey Pines up to Cardiff, and that's what's shown here. So the x-axis is just the longshore distance, starting at the Scripps Submarine Canyon on your left, and then all the way up to the San Elijo Inlet on your right. And then in the cross shore, much exaggerated in scale compared to the alongshore, we have cross-shore distance. In this case, I've straightened out the coastline. Everything is relative to the average or mean sea level contour location, the 0 line there. On this, you can see that there's a fair amount of alongshore variability in the bathymetry. So you have the Scripps Canyon head on the left-hand side, of course, sticking in. So the head of the canyon is very close to the shoreline. But then as you go along the coastline, you have these more complicated areas of bathymetry. These are reefy, rocky areas between the inlets. It tends to be sandy in front of the inlets, and then you'll have a rocky, reefy section as you move down coast between the inlets. So these act as natural barriers to the sand migrating along. And we also find that in our wave predictions that the waves in these reefy sections are not highly motivated to move the sand southward all the time, year round, that they tend to be areas of weak alongshore transport, net transport for the year in these reefy sections as well. So the combination of those two things make the transport of sand along the coastline more episodic than kind of the concept of a river of sand might imply. So this is an example of, so before showing you what the nearshore map of this past fall looks like, of where the sand is, I thought I'd start with one 4 years ago, because this was when our beaches were in really good shape, before we've had a number of, there was a severe storm in January of 2021 that you might remember, sort of a 50-year type event that caused a lot of erosion. And then our atmospheric river winter in 2023, and now the El Nino. So kind of 3 out of 4 years since 2020 have been rough winters. So this back in fall of 2020 was kind of as good as things got before all of that started happening. And so this shows anomalies. This is the sand elevation relative to the long-term average surveyed fall elevations in the nearshore. And so blue means above average amounts of sand for the fall, and red means below average amounts of sand. And so you can see in this plot that the beaches were doing very well. And so a lot of blue very close to the coastline means that above average amount of sand has been piled up, if you will, on the coastline. You can see on the left-hand side by Scripps Submarine Canyon, lots of extra sand piled up around the canyon head. And in this case, the red areas in deeper water in the nearshore zone, those actually are a good sign. That means that sand has been basically pushed shoreward. And so the elevations are lower than normal for the fall because the sand has migrated so efficiently onto the beach itself. So this is what it looks like when the beaches are in good shape. And now this is what they looked like this fall. You can see it's all kind of flipped around for the most part, that instead of being the blue in the near shore, we have blue offshore. So there's more sand offshore than normal. And then in close to the near shore, you see red bands. So in shallow water, we had less sand than normal. You can see at the Scripps Canyon head on the left-hand side, lots of redness around there. So all that sand that had piled up around the canyon head has presumably been lost down the canyon itself. On the right-hand side, where it's labeled nourishment, there in Solana Beach, you can see the big blue area where the sand was placed. You can see in shallow water, unlike the rest of the coastline, in shallow water, it's still blue. So they don't have the red band in the near shore like the rest of the beaches do. And that's because they placed the nourishment in the wintertime. So the beach had eroded and a lot of the beach sand had been deposited offshore. Well, that migrated back towards the beach this summer, but because the nourishment is a coarse-grained sand and has a very steep beach face, the native sand, which is smaller grain size and likes to have milder slopes, couldn't really climb the beach face, if you will. So it appears that a lot of the native sand just sort of piled up in shallow water at the base of the nourishment. And so it got close, but it's not actually back on the beach. You'll also see that Cardiff State Beach is very red. It seems that Cardiff has lost quite a bit of sand over the last couple of years, particularly with these 2 severe winters. Some of it has clearly migrated over the reefs, Seaside and Tabletop Reef, and is also now in the Solana Beach area. So Solana Beach both has nourishment sand, and it actually gained quite a bit of sand, we believe, from Cardiff State Beach as well over the last few years. So Solana Beach right now is very sand rich, and Cardiff is relatively sand depleted. Now, some of the redness and some of the missing sand may also actually be some of the sand that's gone back into the inlet at San Elijo. As people probably know, that they've had a problem with a lot of shoaling in the inlet after they dredged as part of the restoration project. And so more sand ended up back in the inlet than they were expecting. So that may explain some of the loss in the near shore shown here as well. So where did the eroded sand go? Well, it's around. And that's a big take home message here, is that, and this is actually, will segue into the satellite data part of the talk, is that one of our working hypotheses at this point is that sand, other than heading down the Scripps Canyon there on the left-hand side, it's not clear to us that sand is actually leaving the system, the nearshore system, very rapidly. We were wondering if we have offshore sand losses deeper than the 10-meter contour shown on this plot, like if that's a big source of sand loss, that it just gets taken so far offshore beyond what people like to call the depth of closure that it never makes it back. And we're not really seeing convincing evidence of that occurring. Rather, we see more convincing evidence that the sand does stick around. It may take many years for it to come back and show up on the beach again if it's displaced far offshore, and depending on what the wave conditions are from year to year. But it's probably a better assumption to assume that the sand is not permanently lost until it reaches a submarine canyon, but instead, may not be on the beach where you want it. So yeah, just looking ahead in terms of this next winter, in the beach report, if you've looked at the guide before, the way we like to think about it is everything in context of the El Nino La Nina cycle, or ENSO cycle, that when El Nino winters occur in particular, we have beach loss with the sand deposited offshore. And then it takes many years in between the El Ninos, perhaps for that sand to migrate back onshore. So these are recovery periods. And as a result, if you were just look at the time series of annual beach width over time, it kind of turns into a sawtooth pattern with backing up with El Ninos and then slowly recovering in between El Ninos. So what that means is we're kind of at the base of one of our teeth in our sawtooth after the 2024 El Nino. So our expectation is now that the beaches will start to recover over the next few years between El Ninos. This is not a every year advancement kind of thing. It sort of staggers to a wider state, kind of going up and down a little each year, but a net progress towards wider beaches. So that is our hope at this point. So it was 8 years between the 2016 and 2024 El Nino. So compared to the 6 years between 2010 and 2016. So, we're hoping that it'll be another 6 to 8 years before we have another El Nino, and that the beaches will, for the most part, recover in between. In terms of this winter, you can look on the website. We give a probabilistic view of whether or not that it'll be above or below average beach erosion. And it turns out that the probabilistic forecast is for actually slightly above average beach erosion this winter. But hopefully we'll have a good recovery in the spring. And hopefully the average annual beach width may not take a big hit, or even may improve slightly from this past year. A different way to, behind the data that does that probabilistic thing, there's kind of a simpler way you can think about it, and that is whether just looking at what kind of El Nino forecast or La Nina forecast they're giving for a winter. You can compare that to our historical wave information in San Diego County in particular, but probably statewide as well. And you can kind of relate those two statistically. And what it shows is that when there's an El Nino winter, and that's the forecast, but when that occurs, we pretty much have above average waves every winter when it's officially an El Nino winter. So you can almost guarantee that you'll have above average beach erosion. But then it gets tricky that when you have a weak El Nino, then we actually tend to have below average waves 2 out of 3 years. And when we have a weak La Nina, we actually have above average waves 2 out of 3 years. And then finally, when there's a full-on La Nina, again, it's just below average waves, but just 2 out of 3 years. So unlike the El Nino, so the whole El Nino index thing is a little skewed towards positive El Ninos and above average waves for sure. And it gets a little more complicated when it's not an El Nino, if you will, or not a full-on El Nino. And so that's why the ENSO index is not a perfect indicator of beach change or above or below average waves, is because of this sort of stranger behavior for what often people call neutral conditions. For a weak El Nino or a weak La Nina, they'll often just refer to it as neutral. So things kind of wobble through there, if you will, in terms of below or above average waves. So anyhow, most of the forecasts are for a weak La Nina, and so the expectation is that could lead to above average waves, but very rare to have well above average waves during a weak La Nina. So that's why I'm hoping that we may actually see kind of more beach erosion this winter than we would like. But if there are not any really severe winter waves, then hopefully the sand won't go too far offshore. We'll have a nice spring sandbar again. And in fact, our summer beaches will look pretty good. Okay. So finally, I just wanted to talk about next year and our work with satellite data. In particular, it's this Landsat satellite data. So this is Landsat satellites have been up since 1985. Was the first Landsat satellite, and then there's been numerous follow-ons. They're up to like Landsat satellite number 7 or something like that they follow on with a new satellite. And the satellites have gotten better over time. Particularly since around 2000, the quality of the images has gotten quite high. So Landsat, among things, does imagery. And so from that shoreline imagery, you can actually guess at a wet, dry shoreline location. It's a pretty noisy estimate all by itself in a single image, but when you start averaging a bunch of images together, it starts to make some sense. So we validated some of this Landsat imagery against our San Diego survey data set, and we found that if you calculate annual mean shoreline positions from this imagery, that those estimates compare very favorably with similar annual mean shorelines from our survey data. When you get shorter timescales than that, the summer width, the winter width, the fall width or the winter width, when you get into narrower time periods, the uncertainty goes up considerably and biases, but annual averages are quite good. So when we started looking at these annual mean shoreline changes over time since 1985, one of the cool things we found was there's remarkably coherent statewide behavior in terms of these recovery trends I talked about in the sawtooth pattern, that we were rather stunned to see that statewide, the beaches tend to agree on what was a good recovery time period between two El Niños compared to a poor recovery time period between two El Niños. And that was unexpected, but that has many positive implications for using this kind of data set on a statewide basis and applying what we've been learning in San Diego to other beaches in the state, given that they all tend to, or a lot of them, tend to agree in terms of whether it was a good year or bad year for beaches. So this Landsat data set that we're using, we're using code and data originally calculated by the USGS and an Australian research group. It's called COSAT. It's an online data set. University of New South Wales hosts it. And you can see on the right-hand side, that's a map or a picture of the web page that they have, and you can drill in, and they have transects all along the coastline, 100 meters apart, where there are beaches or where they thought there are beaches. And they have this for the entire California coastline, among other places, and goes back to 1980-45. Right now, the online data set goes through 2021. So this Landsat flies over the California coastline every 8 days. It's been doing that since 1985. If there are clouds, of course, you don't get data. There were other issues back in the day. You wouldn't have data. Like I said, the data set gets better over time. So it's not a perfect temporal coverage, depending on clouds, things like that. But it's a long data set, and it's quite a bit of data for each year to average together to get a shoreline position. And so this is what we are beginning with. There are other satellites these days. Planet satellite system is doing a lot of coastal imagery, among others. And certainly we are starting to look at that as well. But in terms of a long-term data set, going back to 1985, it's the Landsat data that's really of interest. And so that's where we're focused right now. So this is an example of comparing annual mean shoreline positions from the satellite data in red to our survey data from Cardiff State Beach as the black lines and the asterisks. And so this is from going back into the 80s through 2021. In this case, we've actually turned it into an actual beach width because of the fact that we could project their stuff onto our survey lines as well. Normally, it's the way we use the satellite data is in a relative sense, relative to its long-term mean location, wherever that may really be geographically. But in this case, I'm showing you an actual beach width estimate from the satellite data. But you can see that they agree very well. And so this sawtooth pattern that we see in the survey data is replicated in the satellite data as well. So we were very excited to see this. And so you can see that it tells a more complete story. For example, Cardiff, where we started measuring, having data back to 1997 with that first NASA LiDAR flight. But if you just looked at the black data there, you would say, oh, that, Cardiff, has just been growing over time with all the nourishments that have been done there and the bypassing, that it's just been a growth situation. But now when you add the satellite data that goes back to 1985, you see a much more V-shaped pattern, that there was, that the beach was backing up, which people knew, of course, at that time, and that was the motivation to start to do beach nourishments by the 1997-98 El Nino, that many state beaches statewide had become badly eroded over several decades. And the thought at the time was that that may be a permanent thing, that we were just losing sand all the time and that the beaches were backing up. That turns out to not be true, that it's part of a much longer beach cycle. And while Cardiff has certainly benefited from nourishments and bypassing, many beaches statewide have grown since 2000 on their own without nourishments. So this is the crazy thing. So we said, oh, this is great that Cardiff does that sort of thing. But when we started looking at other beaches across the state with the satellite data, other state beaches, we saw these amazing self-similar patterns show up. So this is the same data for Cardiff in the red here, is shown in red in the circles, and a linear fit between El Nino years in the gray shaded areas. But now I've added other state beaches throughout the state. So Pismo State Beach, Monterey State Beach, so north facing on the south side of Monterey Bay, and then Salmon Creek State Beach up in Sonoma County in yellow. And you can see that for many time periods in between the El Ninos, they all seem to agree on whether it was a good recovery time period or a bad recovery time period, which was really amazing. We were not expecting to see this. And so, for example, between the 2003 and 2010 El Ninos, the beaches didn't really recover that much. And we saw that in our San Diego data for sure, but it turned out that this was a statewide phenomena, that that wave conditions, for whatever reasons, were not very conducive for the beaches to recover. But between the 1998 and 2003 El Nino, and between the 2010 and 2016 one in particular, there was a great deal beach recovery occurred. And so this is pretty amazing. And what we have linked this to is wave power statewide. So we knew that something had to be happening statewide with the waves in order to be driving a pattern like this. So we just started simply looking at offshore wave conditions, offshore of California, and how those have changed over time. And what we found is that the beaches are essentially responding to whether or not the annual wave power, offshore wave power, whether it goes up and down from year to year, results in the average beach, if you will, in California, also going up and down in an inverse pattern. So if the wave power goes up, the beaches are narrower in general the next year. So I want to illustrate this with this fun animation. So this is, you're looking at a map of the state on its side here, and then there's a little symbol of a buoy offshore here just to represent offshore wave power. And so on the bottom of the plot, you can see that there's going to be a time series from 1986 to 2021 of the year-to-year change in the offshore wave power. We've been measuring it since about 2000. Prior to that, we're using wave hindcast. And in fact, the wave hindcast goes back to 1940. But wave hindcast and the buoy agree very well between 2000 and 2021. So we think the hindcast is pretty good. Anyhow, if you look at the offshore wave power from the hindcast or the buoy, starting in 1985, just from year to year, whether the wave power goes up from the previous year or down from the previous year, and then look at the satellite data, and if it says the annual mean shoreline position, whether it got wider or it got narrower, there's a remarkable relationship between the two for much of the coastline. And so you're going to see on this animation as it goes forward is that when the beaches are wider on average, annual mean beach width is wider on average, it'll go blue. at the coastline with blue bars up, and when it gets narrower, it will go red bars down. Okay, and so I'll start the animation, and we'll see as it goes along. We'll let it loop through once or twice as we talk. So here off we go, and you can see that when so we're going to come up to the 1998. It'll pause slightly at the 1998 El Nino. Big increase in wave power, and you can see all the red of all the beaches backing up. But you can just see how they go up and down together here. Is when the wave power goes up, the beaches go down, and when the wave power goes down, the beaches get wider. Back and forth it goes. You'll see that it's not, and it pauses slightly there at the El Ninos. So you can see it's not every beach, and in fact, some beaches seem to have an opposite behavior. It's going to loop through again here. So there are some beaches that like to do the opposite of what most of the beaches are doing. We're trying to still figure that out, but some of them for sure are cobble beaches, which actually like El Ninos. They tend, as the sand gets stripped away and then the cobbles are free. So in those cases, those might be primarily cobble beaches that are actually going in the opposite direction of the sandy beaches with this variation. But this is really cool, the fact that so many beaches are behaving in a similar pattern. And what it's telling you is that if you can predict what the offshore wave power, if you can forecast whether it's going to be higher or lower compared to the previous year, you have a pretty good guess at what the majority of the beaches are going to do in terms of getting wider or narrower in the future. And you can think of this also climatologically, because many of the climate models that go out many years simulate waves. And so you can look at the long-term time series of wave power that way. Okay. So we have this cool data set that shows that a lot of the beaches, a lot of the state beaches are behaving in a very similar pattern with wave power. So how can we use this data set to kind of help look at historically what a lot of the state beaches have been up to? And so this is an example. I'll just show you a couple state beaches of a possible kind of product that we're thinking about creating based on the satellite data. So these are these annual mean shoreline positions. As I said before, we find they're most useful in giving a relative shoreline change that we're having a little trouble with the satellite data as it's presented now through this COSAT system, actually matching the location it thinks that geographically where the shoreline is to where we think it geographically is. That is not matching up as well as we'd like. However, these anomalies, how it varies relative to its own guess at where the location is compared to doing the same with our data, matches up very well. So for now, we're just kind of looking at the relative change in beaches over time since 1985. So in this case, in a previous webinar or quarterly newsletter discussion, someone was asking about the Tijuana estuary, particularly the south end of the estuary from the Mexican border up to the Tijuana Inlet. We don't survey down there too often with our truck. It's a little hard to get to and is more involved with the Border Patrol and whatnot. But there is this nice historical data set down there. So that's what's shown in this plot. So on the right hand is just a little map, and it shows these satellite transects that are about 100 meters apart along the section. And here I'm using the state parks GIS database, defining the boundaries of their different state parks and state beaches along the coastline. So just using that as the key and then selecting the satellite transects associated with that park boundary, which are shown on the right-hand panel, and then plotting their annual shoreline position anomalies on the right-hand panel, you can kind of start to see interesting long-term trends. So in this case, so that they're colored, so blue transects to the south up to red ones to the north. And you can see there's quite a bit of variation across the park over time and the behavior, and that's because of inlet migration at the very north end. So the red and orange lines on the left-hand side. So you can see back in the 1992, 1998 time period, the north end of the park was actually quite wide in a relative sense. But since that time, particularly since 2016 El Nino, that now that it's gotten quite a bit narrower, and that's associated with the inlet migrating south, that the nourishment in Imperial Beach placed in 2012 was coarse grain nourishment that migrated down the coastline over the following years and blocked the beach. So that shows up there as that variation. Refugio State Beach up east of Point Conception. Here you can see that that's where they've lost a lot of palm trees. You can see that, and that's in those red transects on the far west-hand side. You can see that those naturally have varied quite a bit over the years. And so that may explain why, in fact, they've had trouble retaining those trees. And then here's Seacliff State Beach. This is just an example of how much variation in the longshore beach width we have seen there over time. So clearly that they badly damaged this last winter, but you can see it leading into, so this is through 2021, you can see that Seacliff was actually undergoing quite a bit of a transformation, if you will. We call this beach rotation. When one end of the beach is starting to be wider than normal and the other end of the beach, the north end, was narrower than normal. So there quite a bit of beach rotation had occurred since 2010 at Seacliff prior to the severe damage they had this past winter. And with that, I will conclude and I will take any questions people have.
Well, again, while folks think of their questions, kind of looking at those last 3 slides there, we've been talking a lot with state parks managers about, how do we distill all of this information into something that's useful for you, right? It has a website you can access. Maybe you can see how your beach is doing, compared to the relative time series. Certainly curious if kind of we're headed in a direction that is useful, if something like this was available for all state park managed coastlines. Super interested in that feedback, because the relevancy of these types of products are only going to be as powerful as the feedback we get from the folks who are going to be using them out in the districts. So that doesn't have to be live while we're all talking about it, but again, want to make sure that I'm a resource. Feel free to email me anytime. Really excited to kind of see some of these other applications and make things useful for folks outside of just San Diego District, who I know uses resources like this all the time.
I have a question for Bill.
Yes, Mike.
Question on the earlier slide where it showed an increased beach width in northern Del Mar. Is there any indication that might be due to sand, air quotes here, leaking from the beach nourishment site up in Solana?
Yeah, we don't. No, we don't think that's the case. Just because Del Mar was already running above average before the nourishment was placed, and yeah, as we've been tracking the nourishment as it's been coming down the coast, we have not really seen a significant change in volume on the Del Mar side yet that would indicate that sand was getting across. But yeah, it is tricky that Del Mar is surprisingly has been above average even prior to the nourishment. And that may be because sand has been making its way down the coastline from the north, both from Cardiff and Solana Beach, past nourishments and whatnot, that was starting to show up at Del Mar is a positive thing. So despite these severe winters occurring, Del Mar was running above average. So, but I think it was, yeah, the best guess is that it was benefiting from sand that's been making its way down the coastline already.
Bill, didn't you say also that Solana Beach before the nourishment was actually in somewhat of an accreted state? That it had a
Yes.
lot of sand even before the nourishment?
Yes, that was ironic that it was doing well, that it had gotten some sand, I think, from Cardiff. That when we have these severe winters like the atmospheric 2023 winter and the El Nino, those seem to be the time periods when sand moves from Cardiff over to Solana through the reef system. And Solana tends to actually end up being better off the year or two after an El Nino because of that. So yeah, Solana just happened to be already in pretty good shape for Solana Beach before the nourishment actually occurred. But of course that was planned many, many, many years in advance, and that's kind of one of the tricky things about it. But now Solana has a ton of sand, and it'll be very interesting to see how that moves down through Del Mar and into the Torrey Pines State Beach.
And if I could just kind of bookend my question and follow up on Nick's suggestion, for me, in terms of what I need to do down at the inlet, if there was some way to use your data and monitoring to track the sand from the nourish sites, in a perfect world, I can get a year's heads up of it may be coming soon versus showing up at the inlet at Los Pen and there's 6 feet of additional vertical sand on the beaches. And now it's a fire drill and I have to figure out how to make water move uphill.
Yeah. Yeah, I hear you. That is our hope that we will be able to follow this thing coming down the coastline by both measuring grain size and looking at the steepness of the beach face, as well as sand volumes above, so Del Mar, yes, has been running above average, but now we know what that number is. And so if it rises above that, we can assume that that's probably nourishment sand added to it.
Yeah, and I think if there's any effort to combine your work with Adam's, which I imagine there is where it's
Yes.
needed an overlap. I mean, having that real time of like, wow, we're watching the sand disappear on, hourly increments or whatever the time scale is, I think that would be very beneficial for us down coast managers and relevance to the beach nourishment in North County, San Diego.
Yes. Yeah, I think that because there was already above average amount of sand appearing in Del Mar and even maybe at the north end of Torrey Pines. So, you may be seeing above average sand show up there, but at this point, it's probably pre-nourishment sand that's it's making its way down in a positive sense, which will be followed by this nourishment sand. So yeah, we'll try to differentiate between those two as it happens.
And not to dominate this, I promise this is my last question. In terms of Torrey Pines, I noticed a comment you made about the native sand or natural sand, air quotes again, not being able to move back up to the nourished beach. Do you think potentially that's why we're still seeing narrow beach down at Torrey? Because that storm in 2023 January seems like we lost, well, pretty much all of our sand in most of the lower beach. And it seemed to have modified the beach profile, creating more of a steeper beach profile that is now cobble. Do you think that might lend into the native or natural sand not really getting to rebuild that beach? And I'm talking south of the inlet as much.
Yeah. I don't know. It is an interesting question. Despite the fact that our beaches came back nicely here in the late summer and early fall, and they did, there was a nice bar in the spring that came in. The base of the beach has below average amounts of sand on it. So it's sort of, it did a good job piling up the sand it had onto the beach that we have. But the base of the beach underwater does have below average elevations. And so the expectation here is that the beaches may erode more this winter on kind of lesser events than you would think than normal. Be like, whoa, it's really kind of backing up fast for that size of an event. And that may occur because of the fact that the shallow zone is kind of depleted right now. So there's plenty of space for sand to kind of fall downhill.
I got a question, Bill. I was intrigued by your sawtooth pattern, and I'm wondering what you think with expected sea level rise, how that's gonna change or fall apart at some point.
Yes, I wouldn't. Yeah, what's the expectation there? It'll be slow. It'll be slow. I don't know if it'll fall apart or just sawtooth will get smaller. We do see some beaches. San Elijo State Beach, I think, is kind of a classic one that after the 2016 El Nino, it didn't recover. Like instead, it actually started getting narrower each year after the 2016 El Nino, while other beaches around, including Cardiff, were getting wider. So they may hit a limit where they just don't have enough sand left to kind of do their normal recovery thing. So that's one of the things we're interested in trying to get a better understanding of, if there's sort of some sort of minimum volume in play in the cross shore to actually, have a sawtooth pattern happen.
Thank you. I'm also curious how some of your data could be used to inform future sand nourishment projects. I know often it really just comes down to who's got money to do it, or a need, rather than like, all right, what's going to actually stick around the longest? Like, let's put it near the top of a littoral cell where, I don't know, have the most residence time or likely to kind of bounce around off. But yeah.
Yes. Yeah, those are all good questions. At our summit meeting, we talked a lot about this, that how nourishments are funded and put together and eventually controlled by the dredge operator being available to do it. That's all very non-optimal compared to looking year to year where the sand is and go, this will be a good year to put it here, but that's just not the way the whole thing works. Certainly putting it upstream to travel all the way down through the system if possible is a good thing. But of course, that means that it's, you start putting it up at Oceanside, look at all those inlets, it gets to clog on its way down to the canyon. And so, it does require more maintenance that way versus just sort of operating in a more local in between the inlets way. But those are all good questions. They're all big challenges. This nourishment at Solana Beach is quite large. I mean, the amount of sand that's placed now, on the beach, on the subaerial beach compared to the total volume of subaerial beach volume in that whole stretch of North County. I mean, it's like, 30% of the entire volume typically on the subaerial beach. So it's a really large signal, and we'll be fascinated. We're going to watch it as carefully as we can to get a best understanding of what it does.
Do you recall how many cubic yards that was?
It's around 700,000 cubic yards, something like that.
Okay, yeah, that is big.
Yeah, especially for this area. Yeah, and it's, as you can see, it's kind of well down through the whole littoral cell between Oceanside and the Scripps Canyon. So, yeah, that's just kind of the way it worked out.
Maybe a really quick interjection while we give folks time for the next question. I just wanted to note that, we do this big webinar that talks about kind of the annual recap and, offers some stuff out of San Diego once a year. Looking forward for next year, and something we did this past year was also hold smaller quarterly webinars that are much more focused on kind of the latest and greatest from the San Diego region specifically. I think next year we may be moving to once every 4 months, but either way, kind of an opportunity to check in with this team and kind of get updates throughout the year instead of waiting for, this kind of big annual event. And so, if that is of interest of folks, please email me. I'll make sure to mention it again when this recording goes out, but also a resource that is available to folks if you're not in the loop and you're not getting those updates, but you would like to.
Bill, I
Oh.
wonder if it would be relevant to speak to some of what Riley was talking about with some of the work you did with Shri at Cardiff in potentially nourishing a beach a little differently from the way Solana Beach was done.
Yes, so at Cardiff, we found that between, say, 2000 and 2020, so before they did the major lagoon restoration project, so they were just bypassing on a regular basis every spring. They would bypass some sand, either put it on the beach or put it in shallow water to the south of the inlet. They built this living shoreline dune through some of that time period. But we found that, and so it was between the El Niños, we just found it was amazing how we could keep track. Whatever amount they were reporting, like we would see it in our beach surveys in terms of the nourishments and how the beach width grew there, just with these every year putting 20,000 cubic meters or so of sand, bypassing that each year, each springtime, that the beach absolutely widened with that, and the volume was accounted for, and it all kind of made sense. And, you know, if you weren't plotting it all out, it was just like, it was like the little engine that it just progressively over multiple years built out the beach very nicely. And so it really sort of was kind of impressed us with that, oh, these bypassings, if done well, and I think for the most part, they didn't have trouble with that sand coming back into the inlet. You know, if done every year and done well, are just like a remarkable way to kind of sustain the beach width. And so yes, that we're kind of pro, you know, clever, small amounts, especially the inlet bypassing, see if there are ways to do that better each year and really kind of make it the mainstay of how the beaches are maintained around here, that may go a long way to stabilizing the beaches in ways where these really large nourishments maybe aren't needed so much. And certainly, you know, don't lead to this potential for dramatic amounts of sand moving down the coastline and having to be bypassed all at once from the inlets. So yeah, I think that, you know, looking forward, to think small at first, and just about inlet bypassing, that it can be much more, I think, successful, and really add up over time than people give it credit for.
Well, not hearing a ton of other questions. Also, just one more pitch for feedback on how today's event went. I think we peaked at about 52 people and seemed to have pretty good retention, but, you know, always trying to kind of iteratively improve on these. And, you know, again, the purpose of this is so that it's useful for you. So, you know, please send us feedback. And again, we'll follow up with a recording and all of that once it's all available online.